Alright everyone, so today we're going into answering CIE Paper 2 Chemistry 9701 22 October-November 2019. Let's get into the first question. So in the periodic table, the P block contains the element whose outer electrons are found in the P subshell. So the element in the P shows a general increase in first IE as the atomic number increases. Draw the shape of a P orbital. So let's recap. P orbital will have a dumbbell shape. So just draw a dumbbell shape. Therefore, you will have that one mark. Write an equation to show the first ionization energy of silicon. So recap, ionization energy is the energy needed for atom in gaseous state to change into cations. So here we have silicon. It must be in gaseous state, so it will change into silicon ion by removing one electron. So explain why there is a general increase in first IE of the element across period 3. So when we talk about IE, the factors that affecting IE is definitely the first one is the nuclear charge. So from left to right across the period, the nuclear charge increases. And then we also must talk about the shielding. Across the period, the shielding is constant, or they have a similar shielding between the inner electrons. And what happened to the attraction? So the attraction between the outer electron and also the nucleus increases. So element A is in the P block. The graph shows the successive IEs for the removal of the first 10 electrons of A. So state and explain the group of periodic table that element A belongs to. So in this type of question, you just need to find where a large increase in IE. So as you can see here, there is a large increase between the third and the fourth IE. That means that the third electron is removed from the outer electron and the fourth electron is removed from an inner electron. So since it has 3 outer electrons, that means this element is in group 3 or group 13, because there is a large increase between the third and the fourth IE. So silicon is found in many compounds in the Earth's crust. Silicon has only 3 naturally occurring isotopes, which are given. So the table shows the relative isotopic mass of all of the isotopes. So a sample of silicon contains 92.2% of 28 silicon. So the total percentage abundance of 29 and also 30th silicon in the sample is 7.8. So the relative atomic mass or AR of silicon in the sample is 28.09. Calculate the percentage abundance of 30th CSI. So in this case, what you need to do is you need to multiply each relative isotopic mass to its percentage. The first isotope 28 and you have 92.2%, and then you add another isotope. So in this case you have 29 and you don't know what is the value, so you have X. So plus the last isotope, so you have 30. Multiply with 7.8, which is the total of 29 and also 30th isotope, and minus X, which X represent the relative abundance of isotope 29. So divide by 100 because you want to convert this into non-percentage, and then equivalent to the AR, which is 28.09. So just do a simple mathematical as usual. So you will see that you have X equivalent to 6.6%. And hence, since the 6.6% is for the 29 silicon isotope, therefore the percentage of 30th isotope, that would be 7.8% minus 6.6%, therefore you have 1.2%. So the next one, silicon react with nitrogen gas to form Si3 and 4. So it is a solid with a melting point of 1900 degrees Celsius. It is insoluble in water and does not conduct electricity when molten. So suggest the type of bonding and structure of Si3 and 4 and explain your answer. So as you can see here, the melting point is extremely high and it is insoluble in water it does not conduct electricity. So because it has a very high melting point, that means this compound is a giant molecule. It is insoluble in water because it has a very strong covalent bond in the structure. And it does not conduct electricity even in molten state because there is no freely moving ions, or there is no mobile charged particles. So sulfur-containing compounds such as C2H5SH are found in fossil fuel and produce SO2 when they are burned. So write the equation to show the complete combustion of this compound. So just do a balancing equation as usual. So we have C2H5SH. So plus oxygen, it will produce, definitely because this is an organic compound, so it will produce carbon dioxide. It will also produce water, and because of this, because of the presence of sulfur, it will produce sulfur dioxide. So just do a balancing equation. So you need 2 carbon on the right hand side, 3 water on the right hand side, and then you will need 4.5 oxygen to make it balance. To state why the presence of SO2 in the atmosphere has environmental consequences, describe one of the consequences of the environment. So remember, this SO2 in the presence of nitrogen dioxide, it can be oxidized into sulfur trioxide. And this sulfur trioxide, it can react with water or in the form of rain to form acid rain. Describe one of the consequences. You can describe any of the effect of acid rain. So you can say it will kill or damage fish by lowering the pH of the aquatic supplies. You can also say it will leach nutrient from the soil. You can say it will leach toxic aluminium into rivers. You can also say it will damage or erodes building. Or you can say in terms of it will kill or it will damage plant or cause deforestation. So any of those. So SO2 can react with ozone to form SO3 in 2 different reactions. So in one reaction, SO2 react with O3 until a dynamic equilibrium is established. So state and explain the effect of an increase in pressure on the composition of the equilibrium mixture. So when we talk about a system in equilibrium, so we must talk about Le-Chatelier principle. So according to Le-Chatelier principle, when an increase in pressure, the equilibrium will shift into a side with a lower number of gas particles. However, from here, as we can see here, so the left hand side and also the right hand side has equal mole of gas particle. So because of that, an increase in pressure will have no effect. In the other reaction, a different equilibrium is established at 300 K as shown, so suggest the temperature needed to increase the yield of SO3 at equilibrium. So according to Le-Chatelier principle, when an increase in temperature, the reaction will shift to an endothermic reaction. So since this equation shows a forward reaction of endothermic, hence any temperature above 300 K will increase the yield of SO3. Question 2. Oxygen is the most abundant element in the Earth's crust. It reacts with other elements to form stable compounds, ions, and molecules. So complete the table to give the formula and acid-base behavior of some of the oxide of the period 3 element. Across period 3, the oxide becomes more acidic with amphoteric in the middle. So that means on the left hand side you will have a basic oxide, and on the right hand side of the periodic table you will have an acidic oxide. So here in this case, sodium, which is on the left hand side, it will be a basic oxide, and aluminium, so you have Al2O3. So silicon, you have SiO2, so this is acidic, mildly acidic, but still acidic. So phosphorus, we have many oxide of phosphorus. You can put P4O10, or you can put P4O6, or P2O3, or P2O5, and these are all definitely acidic. And you have sulfur trioxide, this is definitely acidic. So group 2 element forms stable hydroxide, where M is a group 2 element. Beryllium hydroxide is an amphoteric compound. So state the meaning of the term amphoteric. So amphoteric means it can react with both acid and also base. So write an ionic equation for the reaction of magnesium hydroxide with hydrochloric acid. So magnesium hydroxide will react with hydrochloric acid to form magnesium chloride and also water. So this is just like acid-base reaction. However, the question asks for an ion. So magnesium chloride, this is a soluble salt, so it will dissociate into its ions. So you can cancel them, it will be spectator ions. And the only remaining in the ionic equation, you will have just like a normal acid-base reaction. So you have OH negative, aqueous, reacting with H plus aqueous to form water. So two methods of preparing strontium hydroxide are shown. So state one difference between the observation you would make for reaction 1 and reaction 2. Strontium is a metal, so any metal reacting with water, it will cause a fizzing, or it will cause an effervescence. So that would be reaction 1. However, in reaction 2, this is an oxide. Oxide, where it react with water, it will not be producing any bubbles, or it will not be producing any fizzes. So this is the difference, because it is the observation here. So state how the solubility of group 2 hydroxide changes down the group. So down the group 2 hydroxide increases in its solubility. And it vice versa for the sulfate. So the sulfate down the group, it will become decreases in solubility. So the explanation you will learn in A level later. So in AS, you do not require why the explanation because of this. The next one, sodium peroxide reacts with carbon dioxide. So the partial pressure of CO2 in a 0.5 dm³ sample of air is 5.37 kilopascal at 20 degrees Celsius. Calculate the amount in mole of CO2 present in a sample of air at 20 degrees Celsius. So if you look at here, you are given the pressure, you are given the temperature, you are given the volume. Hence, you can calculate this using the ideal gas equation, which is PV nRT. So you have PV equivalent to nRT. So the pressure must be in Pascal. So you need to convert the kilopascal into Pascal. So that will be 5.37 multiplied with 3. So this is in your Pascal. And then the volume must be in meter cube. So you need to convert 0.5 dm³ into meter cube. So that will be 5 negative 4 meter cube. So n is what you want to calculate. So the R is definitely the constant 8.31, and the temperature you need to convert into Kelvin. So that will be plus 273. So just calculate as usual. You will have as 1.10 power of negative 3 mole. Calculate the mass of sodium peroxide that will react fully with the amount of carbon dioxide calculated in 1. So the ratio between carbon dioxide and also sodium peroxide is 1:1. Therefore, the mole of sodium peroxide is equivalent to the mole of carbon dioxide. So when we want to calculate the mass, so we will have mole of sodium peroxide equivalent to mass over molar mass. So just insert inside this equation. So you have the mole 1.1 power of negative 3. Mass is what you want. Divide by the molar mass, which is 78 gram per mole. Hence, you have the mass as 0.0860 gram. So the peroxide ion has a single covalent bond between the two oxygen atoms. Each oxygen atom carries a negative charge. Draw a dot and cross diagram for the peroxide ion. Show outer electrons only. So you have two oxygen together and they are sharing an electron. Because of the negative 2 charge, that means it has 2 extra electron in it. So here you have the extra electron, so with a charge of 2 negative. Let's go into question 3. A series of reactions for phosphorus and its compound is shown. So state what would you observe in reaction 1. So in reaction 1, you have phosphorus reacting with Cl2 to form phosphorus pentachloride. So definitely the first thing that you will see is the yellow color of chlorine disappears. Or you can also say that you will see a white solid or a white powder produced. This is due to the formation of phosphorus pentachloride. As we know, it is solid and white in color. So state the type of reaction that occurs in reaction 2. So in reaction 2, you have phosphorus pentachloride reacting with water. So any reaction with water, this is what we call hydrolysis. So phosphoric acid can be produced by a direct reaction of phosphorus with nitric acid. Use oxidation number to show that this reaction is a redox reaction. So let's go into the oxidation number of phosphorus. Here is starting from 0, and then here it changed into positive 5, hence this is your oxidation. And other than that, the oxidation number of nitrogen, it changes here from positive 5 into positive 4. So this is your reduction. Yeah. So reaction 3 is a neutralization reaction in which ammonia acts as a base. So for a base, according to Bronsted-Lowry, so it must accept a proton. Or according to Lewis, it must donate a lone pair of electrons. So in this case, our ammonia accepts another hydrogen to produce ammonium ion. Hence, it accepting H plus or accepting protons. So that's how it acting as a base. Draw the three-dimensional shape of ammonium ion given the bond angle. So ammonium ion, as you can see, it has 4 bonds without a lone pair, so it must be tetrahedral in shape. So just draw like a normal tetrahedral shape. So you have a normal line, and then you must have a solid line and a dotted line. The bond angle must be 109.5 degrees. So don't forget the charge. So state the industrial importance of compounds such as ammonium, hydrogen phosphate. So any product with ammonia for your level, usually definitely this used as a fertilizer. So phosphorus pentachloride can be used to convert alcohols to halogenoalkane. Write an equation for the reaction of ethanol with phosphorus pentachloride to produce 1-chloroethane. So we have an alcohol reacting with phosphorus pentachloride. So we will produce our halogenoalkane. And definitely you will produce POCH3 as well, and also hydrogen chloride. So state the type of reaction. This is a substitution reaction where the OH is substituted by chlorine. Halogenoalkane can also be prepared by reacting alcohol with hydrogen halide. So you have either HCl prepared using NaCl and concentrated sulfuric acid, and HI is prepared by reacting sodium iodide with concentrated phosphoric acid. So suggest why hydrogen iodide is not prepared by reaction of sodium iodide with concentrated sulfuric acid. So as we know, so H2SO4 is a strong oxidizing agent. What happens is it will oxidize the iodide ion into iodine. So the rate of hydrolysis of reaction of halogenoalkane with sodium hydroxide dependent on the halogen. So still explain the order of reactivity when sodium hydroxide reacts separately with 1 chloroethane, 1 bromoethane, and 1 iodoethane. So definitely 1 iodoethane will be the fastest, followed by 1 bromoethane, and the last will be 1 chloroethane. So for halogenoalkane, the reactivity, it depends on the bond enthalpy. So the CI bond is the weakest, or the bond enthalpy of CI bond is the lowest. And the CCl bond is the strongest, or we can say that the bond enthalpy of the CCl bond is the highest. So because of that, the CCl bond is harder to be broken compared to the CI bond. So when you have a bond that is hard to be broken, so the reaction will be a bit slower compared to when you have a reaction that the bond enthalpy is lower, so it is easier to be broken, so the rate of reaction will become faster. So prenol is a naturally occurring organic molecule found in many fruits. It contains both an alkene and alcohol functional group. To complete the diagram to show the mechanism, so here you will have a hydroxide ion. So this hydroxide ion will be acting as a nucleophile, so it will attack the delta positive. So in this case, the C is the delta positive and the Cl is delta negative. So it will attack the C of the delta positive, which the CCl bond will undergo heterolytic fission. So prenol react with steam to produce a mixture of 3 isomers J, K, and L of molecular formula of C5H12O2. So prenol, when it react with steam, so definitely it will produce an alcohol. J is heated with excess acidified potassium dichromate. It forms an organic product which show no reaction with 2,4-D and pH. So a reaction with acidified potassium dichromate, this is another oxidation reaction. And when there is shows no reaction with 2,4-D and pH, that means it is not a ketone and it is not an aldehyde. It means that J will undergo oxidation into carboxylic acid. It also means that J is a primary alcohol. So we just need to draw the structure of J, which is an alcohol. So you have CH3 here, CH3. The double bond is no longer there, so you have CHH. So you have CH2OH, and this is the OH here. So this OH, this is a tertiary alcohol, so it will not undergo any oxidation reaction. And this OH, this is a primary alcohol where it will undergo oxidation with excess acidified potassium dichromate to produce a carboxylic acid, which shows no reaction with 2,4-D and pH. So K and L are stereoisomer with molecular formula of C5H12O2. K and L both react with heated with excess acidified potassium dichromate to form M, which is C5H8O3. So M form an orange precipitate on reaction with 2,4-D and pH. So give the structural formula of K and L. So from this reaction, we know that K and L is a secondary alcohol, because when it reacts with excess acidified potassium dichromate, it will produce a ketone, which is M, and this ketone will show a positive result with 2,4-D and pH. So the structural formula of K and L will be, so you have a CH3, which is this part, K, so you have 2 of those, and then you have CH, and then you have another CH. This is between the originally C double bond C. So you have the secondary alcohol, and then you have the original from the prenol. So name the type of stereoisomer shown by K and L. This is definitely optical isomerism. So give the balance equation to represent reaction of K with acidified potassium dichromate to form M. C5H12 O, and then oxidizing agent, so you will produce the M and also water. So just do a balancing equation there. So prenol contains an alkene functional group. Describe a chemical test to confirm the presence of an alkene functional group. Give the result of this reaction. So alkene can be tested using bromine water. So you will add a bromine water which is orange in color. So when you add alkene, they will undergo addition reaction, which the color will change from orange to colorless. Prenol can be polymerized to form polyprenol. Draw one repeated unit of polyprenol. In polymerization, the C double bond C will be opened up. So we have the CH3, C, CH3, and there is no more double bond here. So we have H and CH2OH. So the double bond has been opened up into 2 sigma bond. Alright, let's get into the next question. Isoprenol is a structural isomer of prenol. So the series of reactions shows that isoprenol can be used to form Q, a sweet smelling liquid. So give the name of N. So start counting from the right to give the OH the lowest number possible. So you have 1, 2, 3, 4, and you have a substituent at carbon number 3. So start with that. So we have 3-methyl butan 1-ol. So isoprenol is a liquid and nickel act as a catalyst for reaction 1. This one. Okay, so identify the type of catalysis shown by nickel in reaction 1. So since isoprenol is a liquid and nickel, which is a metal, so definitely it is a solid. So since the catalyst has different phase compared to the reactant, so this is your heterogeneous catalysis. So draw the skeletal formula of Q and suggest one commercial use of Q. So in producing ester, the OH of the carboxylic acid and also the H in the alcohol will be ejected out as water. So start with the carboxylic acid. So we have something like this, and then we have a C double bond O, and then you have O. This is starting with the alcohol part. So we have 2 carbon in the alcohol. So this is the ester produced. So for example, used as a solvent or famously as a perfumes or flavoring. Next one, P can be produced as shown. So the progress of reaction 1 can be monitored using IR spectroscopy. So one absorption that can be used is to monitor the progress of this reaction is that the CCl bond at 730 cm -1. So identify another absorption that can be used to monitor the progress of this reaction. So as you can see here, from the statement says that it is used to show the progress of the product form, which is the CCl bond form. We can also identify the progress of the reaction using the bond in the reactant, which is the C double bond C bond. So we have the C double bond C, this is the specific bond, and the corresponding absorption range is definitely, you can refer to your data booklet, so it is between 1500 to 1680 cm -1. So state the reagent needed for reaction 2. So in reaction 2, you have your halogenoalkane change into nitrile. Definitely you are required cyanide ion. So cyanide ion will not come as a cyanide ion at itself. It will definitely come as a potassium cyanide or sodium cyanide. So name the type of reaction that occur in reaction 3. So in reaction 3, so you have reaction with water. So this is your hydrolysis. So the yield of reaction 1 is very low. Explain why. So as you can see here that the Cl is added into the first carbon of your alkene. That means when you turn back into the mechanism, that this reaction actually uses primary carbocation. But this reaction also able to produce a tertiary carbocation, which is here. So tertiary carbocation is more stable. So tertiary carbocation will be produced more. But in this reaction, you are producing a product coming from a primary carbocation. So a primary carbocation is less stable. So that's why it is produced in a very low amount. Why primary carbocation is less stable compared to the tertiary carbocation? Definitely due to the positive inductive effect. So it has a lower inductive effect due to less alkyl group available. That's it, we are done. Thank you everyone, and good luck for your exam.